Hi everybody, my name is Sui. Today I'm gonna discuss the idea about instantaneous rate of change formula using limit. Now first I have a function and I call it f of s, and I have a point here and I draw a tangent line. Don't worry about it. So it will be a, and I will choose another point on this graph. I will call it this point is a1, so it will be f of a1. And now I'm gonna find the average rate of change, which means that the changes in the value of y versus the changes in the value of s, which means the changes in value of I if f of a1 minus 2 f of a a1 minus 2f of a, and divided by the changes in the value of s. Of s would mean that a1 minus 2a. And now I have the formula of the average rate of change. And if you compare it, if you already learned function for you will realize that it's the same as the following interval formula, which means that is minus y1 and divided by s2 minus s1, and if we solve it into this function, it will be the same. And now I want to rewrite this formula into another way. Now I will not call this point is a, I will call it the point is a plus h. H is the distance between these 2 points here. So this will become a plus h, and this will become f of a plus h. And when I sub it into this, the formula is become f of a plus h minus f of a divided by a plus h minus f minus a. And when I cancel a, it will become f of a plus h minus f of a over h. Now I would say why this formula is better than this one, because I will draw a second line, sorry. Because if you use this formula, you have to know exactly where to this particular point is this. You have to know a and a1, but now you only need one point. It's a, and then the distance between these two, so it will be easier. And I will write it in another way. Now we have this second line, and if you realize that like this, and if you realize that if you move this point approach to this point, it will become very similar to the tangent point, but it will never touch this point. So that means h will approach to a, but the distance s is the distance, it can be negative, and if it's approach to a, it means that it approach to 0 because the distance is decreased. So I will write it in the formula: h approach to the 0. We have a limit because s never is never 0. The same as this formula, minus f of a over h. And now this formula is used for the tangent line. It's no more called the average rate of change. We'll call the instantaneous rate of change formula using limits. Okay, thank you.